So last week we talked about databases and C#, right? Kind of in two separate silos. Well, today we're going to take those two silos and kind of push them together. So we're going to use something called an ORM, Object Relationship Mapper. Yes. Pretty much what that means is that for the first years that SQL databases were a thing, it was hard to work with SQL databases. It was hard to kind of go from this weird like query thing to actually using something usable inside of my objects. So this whole idea of an ORM is to make developers' lives a lot easier. So instead of us as developers having to know the ins and outs of SQL and Postgres and whatever database we're working on, it's, hey, I already know C#. Why can't I write C# code to help query my database, to help work with my database? So me as a developer, I never have to know about SQL ever again. That's the idea. Ideally, you shouldn't have to write SQL statements, but you really actually will. It's like once you learn React, you're not really writing JavaScript anymore, but you still have to know JavaScript. So ORMs are, however, with databases. In .NET specifically, our ORM, there's a lot of them out there, a lot of them. The one we're going to be using is Entity Framework. That's the one that's built by Microsoft, that comes pre-installed and everything like that. There are a few other ones out there that have been built by the community because Entity Framework is awesome and a good solution, but it's not perfect. We won't get those formally. We might touch on those later, but for now it's an Entity Framework. And pretty much what that allows us to do is that allows us to create our database, work with our database, and do everything with our database from C#. So let's see this in action. So I'm going to create a new console app, intro to ORMs. Code, here we go. So the first thing we have to do is we need to install some packages. So we haven't really talked about packages yet. So we did a little bit in JavaScript, right? Whenever we'd like yarn add Axios or yarn add some other thing else, yarn add React Router DOM. Well, in .NET, our equivalent, it's called NuGet. That's what it's technically called. What? Yes. But the command is actually .NET add package. This saying, hey, go to my current .NET app, add a package. And the package that we're going to be adding to Microsoft.entity framework. Microsoft. Because I'm terrible at typing.
Are you recording?
I am recording. .NET add package, Microsoft Entity Framework .design. And what this does, this allows us to now use Entity Framework within inside of our project. That's a really good first step. But we still need what's called a database driver. So the database driver is what translates C# into whatever database we're using. So we're using Postgres, right? That's our database of choice. There's a different driver for every database. This is where the magic actually happens. So, because really Entity Framework in any ORM is supposed to work on any sort of database. That's kind of where the magic is. So I can write my C# code, and now I can run it against a Postgres database or MySQL database or Microsoft SQL database or even some NoSQL databases like Mongo and stuff like that and not have to change my C# code. Just change this driver. So the second package we're adding is our Postgres package. And that's what this is. These commands will be in the homework, so you don't have to memorize them or write them down. But now that we've added those two files, what does it actually give us? So now in the CS proj, it says, hey, we're using these two files now. How are we feeling so far? Okay so far? So when working with the database, what do we really have? We have data, right? We have tables. We have the database itself. Whenever we made our projects last week, our employees database, we actually had to create the database and create some tables and create some data. Well, that same idea, we have to use that, except now it's over in C#. So in C#, we need to make something that's called our data context. So our data context is our C# representation of our database. So what does that mean? That means that's where we'll store what tables we have. That's where we'll store the connection string, where the database lives. All the information about our database is going to be inside of this database context class. Luckily for us, we have tools to help us out. So let's first off, we need to create our database intro to orms inside of Postgres. Yeah. So now we're going to scaffold out our database context. .NET EF DB context scaffold. We're saying, hey, our database is located here. Intro to forms. So .NET EF DB context scaffold, create me a new database that lives at this place. So that's going to be our connection string. We are using our Postgres driver. And we'll call it intro to orms context. There's a lot going on there.
Yeah.
Yeah, right? Phew. Database intro to orms does not exist. Oh. So let's unpack that real fast. So .NET, we're using .NET. Nothing too crazy there. EF, those are our entity framework tools. There's a whole bunch of tools that come with entity framework that we get by installing entity framework. DB context saying, hey, we're creating a new database that we want to work with C# with. Scaffold is a term that we've used before, right? Scaffolding is pretty much, hey, build me something so I don't have to write it myself. But this is going to be so generic, you can give me 80% of the way there without me having to type it. And we'll see what this creates. The next up thing in quotes, that's what's called our connection string. Our connection string, you can think of as pretty much the address of the database. Where does it live? Right now, it's just, hey, my server is my local host, so my machine. And my database name is called intro to orms, and that's it. We have NPG SQL. The next up, we say, hey, what is the database? Postgres. And then what we're naming our context. Yes, Jordan.
In the little string you have there, when you got the error before, is the database equals intro to orms? Is that case sensitive?
Yep.
Okay.
Yep. That's why it worked.
Yep.
Do you want to see what this actually makes us? It's nothing too crazy, actually. But over here, we get our DB context class. And we look at it, it's just a class that inherits from DB context. I can call this whatever I want. This isn't anything magical. I'm saying, hey, here's my database. It has all the properties of a database. It lives here. And that's pretty much it. We haven't defined tables or data or anything else magical yet. There's a lot going on here, I know that. But in actuality, we don't need to know what's going on. We got a constructor there that doesn't do anything. We have a constructor that takes some options that may or may not be useful at some point. We have our onConfiguring method, which allows us to state where it is, what kind of relationships we have to do anything crazy with permissions. And we have our onModel creating method. That's a method that's called internally whenever we actually create the models. So there's a really cool, fun term, creating the models. What does that mean? Creating the models means that now we can manage our database tables all by ourselves. Through C# using something called migrations. So remember last week when we told you to add a column or change a table? You have to run like an alter table command or an alter column command? Yes? No? Yes? Well now, since we're no longer running SQL anymore, we're saying, hey, this thing is going to manage what's going on here. And every time we change our database structure, we're going to be changing our schema using what's called a migration. We can actually have migration set up and run in here as well.
Does it work both ways? So if you change the code here, it will update the SQL.
Yep.
But if you change the SQL, will it update?
Nope. This is something called code first database creating. So we're creating our database inside the code first, and then running it down. There is another paradigm called database first, which is, hey, look at this database and then create the C# stuff for me. It's not as popular. It's also not as handy. You also have to know SQL a lot better than what we know. Excuse me. So yeah, changes here will affect there. Changes there will not affect here. So let's create our first table. Let's see this in action.
Yeah.
What is somebody's favorite hobby? That's not fishing. You gotta get fishing. Football. So let's build ourselves a football table. So in order for us to do that, let's think about what we want to store. Let's store teams. Let's store football teams. That's something relatively simple and straightforward. So inside of NAD framework, inside of most orms, tables are represented by classes. So classes, so let's make a new class. So let's call it team.cs. Give it its own namespace. Intro to orms. Model, intro to orms. Public class team. So what does a team have?
Players.
A team has players. Jump right to the hard part.
That's the coach, yes.
Yes. Coach. Name. City. And we'll do mascot as well. Mascot. And we'll do salary cap. Do they have a salary cap in football?
Yeah, but it's the same for every team, so it doesn't vary.
So, here's our team, right? We can probably add some more stuff to it, but this is our database table, right? This is what we want to store inside of our database about a team. But we're going to take those ideas and now think in C# terms. These are no longer columns on a table. I mean, they are. But really, we can think of them as just properties on a class. So we're going to add a coach property, string coach, prop string name, prop string city. The name it's a mascot. We'll come back to that later. So what else goes to a database table? Normally. Some sort of ID, right?
Mhm.
So let's add an ID here, prop int ID. Now what's cool about Entity Framework is that it will pick this up automatically because we called it an ID and go, oh, that's the table's primary key.
So it's the logic's pre-built that
Mhm.
ID.
Yep.
goes with.
Yep, it's a little bit intelligent for you, and it goes, oh, wait a minute, you made a column called ID. This is going to be a database table. That's going to be your primary key.
Obviously, when making additional tables, would you need to specify IDs, or could you go from public class team that ID specifically? You wouldn't have to do team ID or anything like that?
Yep, nope, we would not. So we've made our table schema. We've kind of said, here's our structure. Now let's add it to our database. Over in our context, because our context is just a class, our tables are just properties on that class. So, but it's a new type of stuff. It's a public DB set team called teams. So let's break this down real fast. Our DB set is a type of list. It inherits from IEnumerable and a couple of other things, but it's pretty much a type of list. And we're saying, hey, our list, our database table, contains teams, our team model. So it's going to have an ID, a mascot, city, coach, and whatever else we gave it. And we're going to call it teams. So public DB set schema class, and then table name. This is pretty much the general formula. So whenever we do make a players table and a players class, we're going to have public DB set player players. Jordan?
Does it import at the top auto, or does it need to be imported in any capacity?
If it's in a different namespace, it'll need to be imported.
But since this is all under the intro to orms namespace, it's fine.
Correct. So now that we've added it here, we have what our database looks like in C#. We need to make one of those migrations. Because really, our database is on a new version, right? We're going, oh, this is a new version. We actually have a table now. We actually need to run our first migration. So over here, .NET EF, migrations, add, and then just like a git commit message, we need to add some sort of unique thing here. So added teams. So what this is doing, this is looking at our code, at the database context that we created. It's also looking at our database and going, hey, what's different? And it's actually creating for us the scripts to go in and actually apply those changes to our database. So if we go into the migrations folder that was newly created for us, you see now it's added 3 new files. A whole bunch of numbers, added teams.cs, whole bunch of numbers, added team.design.cs, and an intro to orms context model snapshot. These are all pre-generated files, and the only one that you really need to care about is this added team CS. The designer is just a whole bunch of gobbledygook, and so is this one that you really don't need to know. But in here, in the added teams, this is what's going to be run against our database. So for me, it's always good to go and double check to see what we're actually going to be doing with each migration, just to double check ourselves. So here, we're saying, hey, we are going to be creating a table. We are going to be calling it teams on line 11. The columns that are on line 12, we have an ID, coach, mascot, and city. They all have their corresponding types. And the only constraints we have is our primary key. Yes, Savannah.
How can I set up my ID like as numeric or serial? I can see over there. How can I do over there?
So that's what this is doing right here. You get this constraint.
Okay.
This is making this our primary key.
It's predefined, so
Yep.
you can't.
So it's going to count.
Yep, that's what this is doing right here. Yeah, this table.primary key. This is going, hey, this is a serial. This is going to be auto incrementing by 1 with every insert. It's going to be doing all that stuff for us.
Will your migrations folder keep an audit trail of every single migration? Okay, so you could get to the point where you could have, you pop open your migrations folder and it's like 5,000 things on.
Yes.
Okay.
Typically what will happen, I'll get to in a second. Typically what will happen is that for each release, you'll be stacking up a whole bunch of migrations. Then once you release one, you will kill that folder and make a new one just of that release. Will and then Savannah.
I was just gonna ask, I can't remember, did you set the nullable on the table, on the team CS for coach, mascot, and city, where it's like nullable true? Or is that just an automatic thing if it's not the primary key?
It's inherited from whatever type this is.
Oh, okay.
So strings can be null, right? Ints can't be null by default. So if we had an integer here, then it would say, oh wait, that can't be that can't be null.
So you're gonna get a false response.
Mm-hmm. Yeah, so that's why I always double check and make sure what I'm creating is actually what I want to create. Is like, oh, I actually want strings that are optional, which I do.
How can we do that like a default instead of the true nuevo?
To make it required and stuff like that.
like
We'll get to that later. But we can put attributes on it. Yeah, we can put attributes and stuff on them.
Okay.
We haven't covered what attributes are yet, so it's like we don't need those right now. So right here, that looks good. I have created my context. I've created my migrations. Now I actually want to run my migrations. .NET EF database update. This command is looking at our migrations folder and go, hey, do we have any outstanding migrations? If we do, it's going to run them all, applied it, and done. So that's great, that's fine and dandy. Come in lobbing stuff into a black hole for the past 20 minutes. But now we actually have a database to actually run stuff against. So let's check this out. PGCLI intro to orms. And let's look at my database tables. Hey, we have 2 tables. One table should look familiar, teams, right? The other table is what is used by Entity Framework to handle that migration stuff. Typically, you don't have to open that up. If you're opening up that table, you're probably doing something really wrong. But our teams table, teams, has everything that we have. It has an integer that is a not null. We have a coach, we have a mascot, we have a city, we have a primary key of the index. So yeah, ta-da! We've made our table now in C#, not here.
What happens if I don't want text? Instead, I want different type of the.
Let's say we want to add like year founded or maybe the season,
Mhm.
year, season.
Yeah, so like let's if we had like a date field like
So instead of string, it would be integer.
public daytime day founded or founded date. Mhm. Something like that would be an integer prop int. Would be a number for a team.
Championships.
Oh yeah. Championships 1. Prop double. Let's just throw something on there. Average ticket price. Just throw on something else. So we've done a couple things here. We've added stuff that's not so much a string type. We've also changed our schema. Since we changed our schema, we have to run a migration and apply the migration. So let's run a migration, .NET EF migrations added non-string columns.
What's the just name?
Hmm.
It's just a comment,
Yeah, yep.
like as we do with the
Dash
GitHub
n.
commit
Mhm, yep.
dash n.
Yep, it's just kind of like here's what this migration is doing, because where this ends up over here in our migration folder.
Oh,
If we check out the migration, we're saying, hey, go to our teams table, add an average ticket price. Go to our teams table, add a integer called championships 1. Oh, I misspelled that. And founded date is a date.
And no nullables, false.
Yep. So this is always going to be some sort of 0 because of the default value here. So let's run this migration .NET EF database update. And if we head back to our PG CLI enter to orms, now we actually have all the columns that we want.
do you do something or the file was created like with the default 0? Do you
Nope, that's all derived by what type it is. So, in C#, our default value of an integer is 0. And it's not nullable, so it's literally deriving what's there, and that's how we're creating our database table.
And so we can use the bar chart type. We have to use just text every time.
Yeah, and text is fine.
Oh, okay. And how can we see the foreign key here?
The foreign key?
Yeah.
We don't have foreign keys yet.
Could you show us?
We'll get there.
Oh, okay.
We'll get there. Probably tomorrow,
Oh, okay.
because
The homework is
Yes,
also.
you're thinking like 4 or 5 steps ahead.
No.
Gotta
I
think
think
here.
about the homework today. So maybe about the homework today have a foreign key.
The homework today should not have a foreign key.
Okay.
I can double check that right now.
I hope so.
Me too, because then we're going really fast. Yep, one table. Yep, just one table. So you're great. We have our table now. How do we use it? So now that we have our table, let's head over to our program CS. And now let's let's do some team stuff, some team building. So as with our database stuff we did last week, we did a couple different types of queries, right? We did what? Create, insert, select, update, and delete, right? So create, insert, select, update, and delete. So the very first thing we have to do before we do anything else is that we need to create a new instance of our database context class. So var db equals new intro to orms context. All that's doing is saying, hey, I want to use this database. You okay there, Andrew?
So are you creating a copy of it, or just?
I'm just pointing to it, and that's it. I'm not creating a copy because it's still only one database that lives on my machine, but I just need some way in C# to kind of talk to it. You can think of this as kind of like a gateway to our database. We're saying, hey, I want to go to my database and I want to get something. So if I wanted to add a new team, what's someone's favorite football team? All right, favorite team
The Wallabies.
is a new team. Mascot equals the Wallabies.
Oh, sure. Yeah.
Yeah.
You said, footy's footy.
Yeah, exactly. We didn't specify it was American, right?
We did it. We did it. We did it. Is that an actual team?
Yes.
Oh,
Okay.
I don't think so.
Who's their coach?
Oh,
All right, cool. Jordan is.
It's rugby.
Championships 1, 3. Average ticket price about $350. And founded date equals datetime.now. Founded today. City equals
Sydney.
Sydney. Sydney.
Whole area they play in, but it's okay.
It's a national team.
Works for me. So if I want to create this team, if I want to add this team to my database,
What's that ticket price?
me too.
Is that Aussie dollar or US dollar?
It's only US dollars. So our database context. Remember we added the teams property to our database context? And that teams property is a DB set, which is just a fancy way of saying a list. And that's it. And we worked with lists last week, right? I saw y'all worked with lists a lot over the weekend too. So it's teams dot add favorite team. And then db dot save changes. And that's it. So we've created a new instance of our team model, gave it a whole bunch of properties. And then we're like, hey database, hey context, add this to the teams table and then save your changes. So if I wanted to do this last week, this would be the same as insert into teams, right? And then comma separated list, mascot, coach, et cetera, et cetera, et cetera. Values, Wallabies, Jordan, et cetera, et cetera, et cetera.
One thing that always gets me is the comma on the outside of the quotes, which is the opposite of how we do it in actual words.
like this right here.
Yeah, we would have. Yeah, it'd be inside.
Yeah,
I
right.
messed that up so many times.
Grammarly hates that. So let's run this and see what happens. So I'm going to run this. I expect it not to crash. And I expect no direct user output because we don't have anything. But I expect it to insert one row into my teams table. That's my expectation. So ran didn't crash. And if I come here, select star from teams. There's our one team.
Like how specific the founded time got.
Yeah, right?
It's like
Yes.
right when the ink dried.
So here's when I signed it this exact millisecond. So let's add a few more teams just to just to have it. Oh God, Patriots. We have what's someone else's favorite teams? Cowboys, the Eagles, Cowbots. Give some people there. And then for us to add each one, dv.teams.add favorite team 2. So all we're doing, quote unquote, all we're doing is we're taking objects and adding them to a list. So it's nothing too crazy. That list just happens to be a database table.
Can you comment that first one out? Because it's already there.
Yep.
Okay.
That would just been duplicated.
Yep.
In my capstone, I have a user registration, and so when I click my button, I'm going to call a object, and I'm going to put it like db, like that.
Yep. Yep. For your captions, you're probably going to have some sort of form or something like that where
Yeah.
people type such stuff in. Click an add button that sends off a API request to an API.
Oh, okay.
And that API is going to take whatever you got it, create a new object, and then save that object to the database.
It's weird coding for something in like real time as compared to like coding something to like do later. Like having to like comment that one out because it's already there and
Yeah, right.
all these others in. Usually I'm trying to like make a website for somebody else to use at a later time.
Hey. Yep. It's a very popular city. So that's awesome. Let's worry about the other parts now. Querying, right? Data's great. We can insert data all day, but we need to actually read it out. So typically, if I wanted to get all my teams that were the Patriots or the Eagles, let's pull out two of the best teams in the world. If I wanted to get the Patriots or the Eagles, it would be something like this, right? Select star from teams where mascot equals Patriots or mascot equals Eagles, right? Anything too crazy there? This should give us back all the columns for those two rows. So here, var those teams. Go to our database. So go to our database context. db.teams. And because teams is a DB set, which is a list, we get all of our link stuff that we talked about last week. Using system.link, db where team.mascot equals Patriots or team.mascot equals Eagles. And now we can actually print those out for each team and those teams. Console.writeLine team.mascot and
Es better than Postgre. It's better than Postgre. The code.
So now I run this, I should get not a build error. Oh, double quotes. There we go. So querying works just like how we would do our maps or selects. And really the magic is that we're only doing C#, right? We're not worrying about what our selects are, what our wheres, what our inserts are. We're only doing kind of what we did last week, and that's it. How do you feel?
I think what's gonna bite me in the butt is remembering to comment out, like adding, like when you comment it out, add the team. It's like if you forget to do that step, it feels like do this, then go back, take out this, then go this.
Typically,
So-
those two ideas exist in separate functions in separate places,
Right.
and never at the same time.
Exactly.
So, like, that won't be an issue in a week. Hell, that won't even be an issue tomorrow.
Okay. Because I can see myself adding it.
Oh yeah,
Then it's
I've done that before. Like during lecture, I've left in those lines and just kind of kept on running it and running it and running it. It's nuts.
So just, I don't know if it's related, but obviously we're doing this in the program where we're doing all this data. In real life, that's not how
Right.
users are going to enter things in database even. So we're just, from a developer standpoint, you're just really creating the structure.
Yep.
And you might be populating some of it just to test it out.
Yep.
But it's not how it's gonna be used later on.
Right. Yep. Tomorrow or Wednesday, we're going to be actually getting into building our own APIs. And we'll be using this inside of our APIs to talk to a database.
How long till we, well, I guess that'll be part of it, never mind. I was gonna ask how long till we like kind of connect it to like React on the front end, but I guess once you're doing it, okay. Once you're making the APIs, it's just a matter of calling to the APIs,
Yep.
so.
Yep. Yeah, this week you're building a database tonight. Then you're putting an API around it next, whenever that next is. And then you're putting, then from there, you're going to put a React app on top of it. So this week is technically the week where it all comes together. We're all, you see the light kind of thing?
Like at the end of the tunnel?
Yeah. So yeah, that's kind of the
Full step.
yeah. So let's do update and delete. Inside of our update and delete. So the general flow for both update and delete is to, can you see that in the back all right?
Yeah.
Okay. Is to find the item we want to update. Update it. And then save the changes. So it's find it, update it, and save it. It's three different things. So let's find it first off. So we're going to query for it. Let's do, let's update the Eagles to no longer be in Sydney because they're really not in Sydney. So I'm going to go, hey, find the Eagles, which is db.teams.first or default. That's a new command. Team.mascot equals the Eagles. So without any sort of help, what does first or default give us? If we had to guess.
So if it doesn't find it, then pick the first one?
So
Sure.
close, Jordan.
Presumably it's gonna scan the mascot column and teams for the first entry of Eagles, or if their Eagles does not exist, whatever the default value of that column might be.
So not of the column, of that type.
Of the, okay.
Yeah.
So
Yep.
yeah, and the column's associated with the string type because it's alright. So
Yeah, so it would be, so if we go, hey, our first or defaults, you're right, scan me the entire teams table, find me the first team where this is true, so find me the first Eagles, and return that one. If I hit the end, return to me the default value of whatever this is, which is null. So it's either going to find it, or it's going to give me back nothing. Yeah, that's how we find one. This is kind of the equivalent of, hey, select star from teams where mascot equals Eagles. But it's only select top one. So select the first one from Eagles or from teams where Eagles equals that.
But is the database the database don't find going to send you zero,
Nothing. Yeah.
nothing.
Yep. No.
So going to send you null also? And the Eagle is
Yes. Yep. If it's not found,
zero. So we have to ask where it's not null Eagle.
Yep.
Before.
so we first need to check to see, hey, is Eagles, if it does not equal null, that means that it was found. Then we can do Eagles dot city equals Philly. Sorry for me.
Oh, why?
that bugged you, huh?
Yep.
Yeah, so if it's Philly, that's awesome. Change it. Then after we're done changing it, hey, db dot save changes. So we're doing our work, we're finding, doing all of our stuff, but it's not saved to the database. It's not made permanent until we call db dot save changes. So let's run this. Then once we run it, the Eagles are now in Philly.
Now, this is fully sequential, right?
Yep. Yeah.
So if you were to pop that above, then it would have displayed out there.
Yep.
Um,
So if I run it again, we should get the Philly Eagles. And how many championships have they won, Andrew? You know, one?
Yes.
Good for them. And then what else? Eagles dot. That's good enough. Average ticket price.
Probably a lot more. Like $100.
Since day one.
$10.10. What's your drama? It's $200. And now if we run this, come back over here, we say, hey, things are starting to get updated, things are starting to change.
If you wanted to format the founded date to just be the date without the minutes and hours.
So you could change it to be just a date type.
Yeah.
And that's a matter of changing its type. You could also not worry about that until you actually pull it out.
Okay.
Because typically with dates, even though we only really care about the date, right? It doesn't hurt us to store the time either.
Okay.
And that's going to be more of a UI thing, more of a presentation logic thing,
Okay.
than something that we do inside the database. Jordan.
Why did you remove the 0.10? Is it because the average ticket price is being displayed with a little decimal point at the end, or
No.
no? It doesn't matter. With the double, you don't have to specify.
It'll still work.
So if you wanted to update multiple things,
Mm-hmm.
you go back to using the .where instead of the first
Yep.
default.
Yep, so if I wanted to update both actually everyone else, and let's set championships 1 to 0 for everyone, just kind of not like set them back to nothing. Update a multiple. var teams to update equals db.teams.where team.mascot does not equal the Eagles, so give me everything but the Eagles. And then for each team to update, team and teams to update. Team.championships1 equals 0. And then db.save changes. So we're still following the same kind of idea. We're finding them, then we're updating them, and then we're saving them. There's not much there to show because it's supposed to be kind of relatively straightforward. Like, the hardest part of all of this is making sure you install your packages correctly. And like kind of get everything, like the first 20 minutes, make sure that goes smoothly. And then to delete, let's remove the Patriots because no one likes the Patriots. So if I wanted to delete the Patriots, I would be, hey, delete from teams, right, where mascot equals the Patriots. Or something a bit more close to what we'll be doing, where ID equals 2. So just like kind of update works, we want to find the thing to delete. We want to, delete it, and then save the changes. So in order for us to find it, var that team equals db.teams.first or default, team.id equals 2. Then delete it, db.teams.remove that team, and then db.save changes. What's up?
Run the code. You run the
You, could it be refactored to, instead of using that team, if you just put the db.teams all in the remove function?
Mm-hmm. Yep. Yeah. But a lot of times it's going to be wrapped in a if that team is not equal null.
The players thing would be the hardest because it's many to many, right? Or
Yep. So we fill in with the basic kind of inserts and wheres and updates and stuff like that. Angie?
If you go up to where you had the word statement, going back to kind of what piggyback on what Andrew said, if you had two conditions where this equals this and this equals that, how would you write it?
It would look like this instead of the double
So you
bars.
don't have to do another where statement. You just
Right. So you could though do a second where statement. If you really wanted to and break those out, you could. But normally this is also a thing as well. So you could do it either way.
Okay.
So like if we wanted to grab we could do stuff like this, db.teams.where team equals team.mascot equals the Patriots dot where actually you can't, I'm sorry. I lied.
it would have to be.
It'd have to be like that, yeah.
You can't just do it where this, where that. It has to be where
Yep.
this and
Because it's all about order of how they execute. So it's going to go with teams and go, okay, it'll give me all the teams that are Patriots. And then of the teams that are Patriots, are there any that are the Eagles? So if you break it out, it becomes more of like a logical and than a logical or. So let's say we had players. How would we do this? So players are going to be a second database table, right?
yeah.
So that's going to be a second class, right? New C# class. players. CS. It's going to have an ID, prop, string full name, prop, string number, string, and let's give you
Position.
string position. Let's give you prop double salary.
Boolean true, integer.
Just to see a Boolean.
Yeah.
Just for the Boolean.
Yes, injured equals false.
And so you can default set stuff by just doing
So now we have a player, right? But a player in teams, they have a relationship. So what relationship do they have? It's a one-to-many, right? One player belongs to one team, but one team has many players. So it's going to be a one-to-many relationship. So with that, let's head over to our team. And what this is, it's now going to be prop list players. Yeah, list of player. Using system, bring in member usings equals new list of players.
So what did you do there to get rid of the red squiggly
Oh,
lines?
just using system.collections.generic.
Oh, okay.
I had to bring this in so I can get the list stuff. So this is me going, hey, my team, each team has many players. So we've defined the many part of the relationship. So let's go over and define the one part of the relationship. Over here, our team stuff, well, it's going to be taking the form of team ID, right? And we go, hey, each player has a team. Because if I look at one player, if I just look at Tom Brady, the only player that I know in the NFL, he has some properties, right? Part of his properties is that he belongs to a team. He plays for the Patriots, and that's about it. He doesn't play for any other team. So we have to say, hey, he has a team. On the other side, the Patriots have many players, and that's where that list comes into play. How do we feel about this so far? So now, since we've changed our models, we need to add a migration. We need to run the migration. So .NET EF, migrations, add, and it's called added player table. Build failed. What?
That parenthesis right there in that other one.
You were waiting, weren't you?
Yes. I saw it before and I was just like, I wonder if this is
I want to be the star.
So that's the malicious part of it. It's like, I want to see what happens. I'll let it happen and I'll bring
I'll be the hero.
Yeah.
That's what's in. I know.
All the person incredible is right there.
So let's check out that migration that it created for us. It's saying, hey, create a new table called player based off of our player class. So it has full name, number, position, salary, injured team, and everything like that. All the correct types and corresponding types. And then down here, it's going, okay, players have a primary key called ID because we gave it an ID. Oh, but wait, we also have a foreign key. Our foreign key is set up that says, hey, on this new table players, we have a foreign key. Our column is team ID, and that points to teams. So that's doing the foreign key relationship for us automatically. It's doing that because we said, hey, everything has a team, and we have something called a team ID here. So because it says team, team, and team, that little triangle of stuff there, those three teams working together, it's smart enough to figure that out based on the naming convention that that's my foreign key.
So why is it saying that there's 0 references if it's referencing the team on the other page?
Because I haven't done anything inside my code yet. I bet you if I go over to my teams, gonna have a whole lot of references right here. Yeah, 6.
Oh, okay.
Good question. So now let's run this, .NET EF database update. And now, if I head into PG CLI, GT, I got my extra table there, /d players. There's all my table stuff. So that's fine and dandy. EA can model it out. But now, if I actually wanted to add a player to a team, let's come down here. I'm actually going to delete this just for now. If I wanted to add a player to the Wallabies, I'd have to first off, find the Wallabies. Then I want to create a new player. Now, instead of me adding that player to my db.players thing, I can just do, hey, wallabies.players.add. And then save my changes. And then save changes. So let's find the Wallabies. Var Wallabies equals db.teams.first or default. Team.id equals 1. Then I create a new player. Var Jordan equals new players. Jordan injured false. Number, what's your favorite number?
13.
I
Really?
thought it was 21.
Liar.
That's the first one on top of my head.
Or was it 382?
31. 32.
Yada, yada, yada. So I'm not going to set the team ID or the actual number. Why are you calling me an issue? Because you're not a string. So now I can do wallabies.players.add Jordan. And db.save changes. So now when I run this, .NET run. So only because I'm treating it like lists, but it's really that relationship. So it's abstracting all that complexity. Is like, oh, what's my foreign key? What do I need to line up the key here? What is it? and it's kind of removing that from you, just going, hey, if you add it to the list, I know what you mean. So if I do select star from players, we get Jordan, who has team ID of 1.
So your ID is your index ID, but the team ID is your primary ID?
So my ID over here is my primary key for the player. My ID over here is my foreign key to the team.
And then which one's the index ID?
The primary key would be the ID.
Okay.
I'm not quite sure what an index
Because
ID is.
on one of the screens that you were going through, it had a foreign key,
Yep.
an index key, and
Oh,
a
yes.
primary key.
The ID is the index.
Okay.
Where do you write the team ID? Or do you-
I actually didn't. That's coming to you because of this right here. So we're saying, hey, our Wallabies is a team that has an ID of 1, right?
Okay.
And we're saying, hey, add Jordan to that list that's on here.
Okay.
This right here is filling in the holes for you.
Esa es la first.
Yep.
It's just a lot of data entry. That's what it feels like.
It is. This is like oh, this is just inputting data and stuff like that. Because it kind of, to me, it almost hides away the magic of what you're actually doing, which is a good thing. But it feels a lot more, a little bit tedious and like, oh, I got to do this, got to do this, got to do that kind of thing. For tonight's homework, you'll be creating a database for me and writing a couple queries using LINQ and C#. So it's, can you get something up and running? Can you get something building? Can you actually create a database with Entity Framework that does something and run some queries against it? That sound good? I mean, it has to. All right, homework will be out. I'll see y'all for with me at 3, and we'll do another project with this. So
Is the content on the homework for the tables already specified?
Yep. We're going on Safari, and I need a database to track